Hello, geometry students. Welcome to 3-7. The lesson 3-7 is about slope and finding equations of lines. This should be a review of a skill that you learned, or a couple skills that you learned in algebra. But it's okay if you don't remember them. We're going to work our way back through them right now. So don't feel bad if it's not something you remember. All right, so we are going to look at how to find slope. First of all, to find the slope m of a line, divide the change in the y values by the change in the x values from one point to another. Slope is rise over run, or the change in y over change in x. Remember that rise is change in y because the y-axis goes up and down. That's your rise. And the run is the change in x because the x-axis goes left and right. It's running. Okay? So the problem says, what is the slope of the line through points -5, 3, and 4, 9? So we need to remember that these coordinates are in the form, let me go to freehand, the form x, y. And if there's 2 points, that's where they get x1, y1, and x2, y2. So let's write that out here. So this -5, 3 is actually the point x1, y1. It's really just an xy coordinate, but since it's the first point, we put the sub 1s in there to signify which one of these is the first point and which one of these is the second point. So 4, 9 being the second point, we're going to call that one x2 and y2. x2, y2. That actually is a 2 right there. Hope you can see that. 2. Okay, we're going to switch to text in a minute because it's much better than me writing or trying to draw. All right, so this gives you the formula, the change in y over change in x, which is y2 minus y1 over x2 minus x1. We actually really need to write that also. So the change in y is y2 minus y1. But if you have no idea what y2 or y1 means, then that doesn't really help you, which is why I wrote this out above these points. So y2 minus y1 is your change in your y's. I do hope this is a review for you, and this is all making sense and coming back to you. And then the change in x is x2 minus x1. So x2, promise I'll start typing in a minute, and this won't be so ugly. x2 minus x1. Okay. All right, so looking at the problem here, it says the change in y over the change in x. So they just substituted in the values, y2, y1, x2, x1, from the points that were given. The y2 value is 9, and the y1 value is 3. So 9 minus 3 is how they got that. The x2 minus x1 is x2, which is 4, minus x1, which is -5. Now notice here that you have minus and negative. Remember that minus and negative is the same thing as plus, which is why when you simplify the denominator, 4 minus -5 is the same thing as 4 plus 5, which is 9. And then, of course, simplifying the numerator is 9 minus 3, which is 6. So you end up with 6 over 9, or 2 over 3. So we're going to practice this down here in our exercises. So finding the slope of a line passing through the given points. So we have x1, y1, and x2, y2. So we're going to substitute those values in. At the top, we need y2 minus y1. So we're just going to take our second y value and subtract our first y value. So we're going to start with 8 minus 2. Yes, that is much prettier, isn't it? Okay. So x minus 2, and then we'll draw a little line here. You do still have to do a little bit with my drawing. Okay. And then on the bottom, we're going to say x2 minus x1, our second x value minus our first x value, or 1 minus -5. Oh, that's not right. Minus parentheses -5. That's better. Okay. So when we simplify this, remember that minus and negative is the same thing as plus. So on top, let me go ahead and put my little division line in here. On top, we have 8 minus 2, which is, of course, 6. And on bottom, we have 1 minus -5, which is 1 plus 5, which is, of course, 6. So, again, we're going to simplify this a little bit further. And 6 over 6, of course, is equal to 1. You could leave it as 6 over 6. It's not wrong. It's just not really in a proper form that you would see anywhere. You would actually simplify 6 over 6 to 1. So let's change color for our next problem. Okay, so we're looking at number 2, and again, we are going to follow our y2 minus y1 over x2 minus x1 formula to find the slope of this line. So I'm going to go ahead and put some symbols in place here and get this all ready to type into in hopes that I can just type this time. All right. So y2 minus y1 is going to be 4 minus 8. We're taking our second y value and we are subtracting our first y value. And then in the denominator we have x2 minus x1, so we're taking our second x value, we're subtracting our first x value, or we're saying 2 minus 1. So then we just need to simplify. 4 minus 8 is of course negative 4, and then on bottom 2 minus 1 is 1. And again, you could leave it like this. It's not wrong. It's just not in the form that you would normally see it. When you have 1 in the bottom of a fraction, you don't really need it. So negative 4 over 1 is really just negative 4. So that's how you would see that answer. All right, let's go ahead and change color again. And look at number 3. Number 3, again, wants us to find the slope of a line passing through the given points. So let's set up our fraction bar so that we can just type right on into it and see if I can get better and better at this as we go and make your life and mine a whole lot easier. Okay. All right, so y2 minus y1, or the y2 value is negative 4. We're going to subtract negative 3. So we've got negative 4 minus a negative 3. We'll clean that up in just a minute. And then the x values, x2 minus x1. The x2 value is 2, and we're subtracting negative 2. So we have 2 minus negative 2. So when we clean this up, remember we have minus a negative is the same thing as plus. So in the numerator, negative 4 minus a negative 3 is the same thing as negative 4 plus 3. Negative 4 plus 3 is, of course, negative 1. And then in the denominator, we have 2 minus a negative 2, which is the same as 2 plus 2, which is 4. And negative 1/4 is really all you need here. Now you could rewrite it just a little bit differently than that, just by putting the negative in front of the whole thing, but it's not necessary. You could just say negative 1/4 if that looks better for you. Okay? All right, so for the next part, we have if you know 2 points on a line, or if you know 1 point and the slope of a line, you can find the equation of a line. And they give us a problem here to kind of walk us through that process. Write an equation of a line that contains the points for negative 5 and k, negative 2, and 1. And it's just to graph the line. Well, we can easily graph the line just by plotting those points. You can see here that 4 and negative 5, 1, 2, 3, 4, and negative 1, 2, 3, 4, 5. Point J is right here. And then we can plot k at negative 2, 1, negative 2, and up 1 is where point k is. Then you can just draw a line between them. But graphing isn't really our battle here. We need to be able to write the equation of a line. So the first thing we need to do, if we don't already have it, is we need to find the slope. So you can see that's what they've done here, using that slope formula of y2 minus y1 over x2 minus x1, and they've substituted in their values. The y2 value is 1, the y1 value is negative 5. So they said 1 minus negative 5. The x2 value is negative 2, and the x1 value is 4, so they have negative 2 minus 4, and they simplified. 1 minus a negative 5 is 1 plus 5, which is 6, and negative 2 minus 4 is negative 6. So they have 6 over negative 6, which of course simplifies to negative 1. That's our slope. We're not done. So if you have the slope and a point, and we actually have 2 points, but you can pick either one you want, you can put it in point-slope form. So now that you know 2 points in the slope of a line, select one of the points to substitute for x1, y1 in the point-slope form. And here's the point-slope form. Y minus y1 equals m times x minus x1. And then you're just substituting things in. M is your slope. So you're going to put this negative 1 slope in for the m. You see that's what they've done. And you're going to put either one of the points up here in for x1, y1. It looks like they chose negative 2, 1, probably because they're smaller numbers. So they substituted in the negative 2x value in for x here. You see that they substituted that in here. And they substituted in the 1 for the y value in for y1 here. Now this y and x, just the plain y and x, those are going to stay in the equation so that you can simplify it. Now this is the point-slope form. It is a perfectly valid and correct form. Okay, this is the point-slope form. Are we going to color right now? Let's see. We are. Okay, so let's go ahead and indicate that. So the correct point-slope form of this line is right here. There's absolutely nothing wrong with that equation, okay? And they show it again down here. Perfectly valid, acceptable answer. But you will often be asked to solve for y or change it to slope-intercept form. And that's what that second form is. So let me switch colors here just so we can signify the different form here. So this actually is slope-intercept form. So that's a perfectly valid form also. And see, all they did here was they distributed the -1 through the parentheses. So -1 times x is -x. -1 times 2 is -2. And then they just solved for y by adding 1 to both sides. So after they distributed, and I'll show that here, they distributed that -1 through the parentheses to get to this step. And then they just added 1 to both sides. Plus 1 to get their slope-intercept form. And that slope-intercept form is also a very valid form. So here's a slope-intercept form. Here it is again down here. And those are both acceptable answers. They are both completely correct equations for this line. It just depends on what you're looking for. If you have a point and a slope, you can put it straight into point-slope form. If you have the slope and the y-intercept, then you can put it in slope-intercept form. If all you have is 2 points, then you can find the slope and then take one of those points and put it in point-slope form. So you got all kinds of options here, which you're going to practice and work with on the second page, and you're going to do that on your homework as well. So for graphing each line here on the 3-7 reteach, I'm actually going to switch to the Word version of this worksheet so that you can see a little bit better. I'm going to move up here and show the Word version of this worksheet. There it is. You can see that this is the exact same worksheet, but when it's in Word, I can draw straight lines on it. And well, at least my classes have seen that I am horrible at drawing straight lines on PDF Escape. So we're going to go over here to the Word version of it. This is graph each line. Now number 4 here is already in slope-intercept form. So we can identify the slope. Let's see, we can identify the slope. I think I can write here. Yep, this is the slope. Slope represented by m. We can write that up here. M is the slope. M equals slope. There you have to deal with me trying to write again. Sorry about that. This is a slope. Now, when you're dealing with something in slope-intercept form, y equals mx plus b, which I sincerely hope is familiar to you. Y equals mx plus b. Whatever's after the x, that is the y-intercept. Okay, so this, which is -4, that is your y-intercept. That's your y-intercept. So it gives you a starting point on your graph, which is great. It's the beauty of the slope-intercept form. Slope, intercept, y-intercept. Okay, so the y-intercept is quite literally where the graph is going to intercept the y-axis. The answer is in the question. So the y-intercept here we can see is -4, so we are going to start at -4. That's on the y-axis. That's our starting point. Okay, and our slope is 1 over 2. Rise 1 over 2. So on the graph, if we rise 1 and run 2, we're going to be right here on the graph. If we rise 1 and run 2 again, we're going to be here. And just keep going until you run out of graph. Rise 1, run 2. Okay, so now if we go to our draw, then we should be able to draw a perfect line. Oh no, did I forget how to do that? Insert. Oh no, I can go to insert. Pictures? No. I might have forgotten how to do that. Shapes. Why isn't that working here? Okay, well that's not going to work for me then. But I can go to draw, and I can draw a line. Sorry, that isn't going to work for me. Okay, so I can at least draw a line with this pretty color. So I can connect my dots here. Oh, this is better than the PDF Escape. And there's my graph for number 4. And I'll save this and upload it to Canvas also so that you can see the graphing and you can see the notes on the other page. So for number 5, we have a point-slope form. So remember with point-slope form, switch to green here. With point-slope form, you have your slope here. That's your slope. M, your slope right there. And then you have y1 and x1. So this is your x value of your y-intercept. Well, just not y-intercept, but it's just one of your points. And then this is going to be the y value. And if you look up here at your notes up here, you can see that in the point slope form, it's y minus y1. Y minus y1. So that minus is already part of the formula. So remember up here, when a positive 1 was the y value, it said y minus 1. And when a negative 2 is the x value, it said x plus 2. So basically you're just switching the sign when you're looking for what your point is on your graph. So a point on your graph for this one, the x value, it says plus 3. So it's actually going to be a negative 3 because in the formula it said x minus x1. So for the y value, I see y minus 4, so that's actually going to be a positive 4 for my y value. Okay, so now graphing this line, I need to start with the point that I have, which is negative 3, 4. So I'm going to go negative 1, 2, 3, and up 4. 1, 2, 3, 4. So this is my starting point. And then from there, I'm executing a slope of 1/3. Rise 1, run 3, right there. Again, rise 1 and run 1, 2, 3, right there. You can actually go backwards also. If it's a positive 1/3, that's going to be the same thing as a negative 1 over negative 3, because in math, 2 wrongs make a right. So you could go down 1 and back 3 and put a point there also. And you can see that all these line up in a perfect line. So if we can draw a straight line through these, then we'll be good. Hey, that's not bad. Okay, so there's our graph for number 5. So looking at 6, again, you can see that we have this in point slope form. Point slope form, choose my other color here. So I can see that I have my slope of negative 6, which is the same thing as negative 6 over 1, or down 6 over 1. And I have my starting point here. My x value is a positive 3, because remember, switching the sign here. The formula says x minus x1. So minus a positive 3, put my 3 right there. And then for my y value of my starting point, it's also going to be a positive 3, because again, the formula is y minus y1, so my y minus 3 is y minus y1. Okay, so we're starting at 3, 3. Over 3 and up 1, 2, 3. Remember that your points are always in x comma y, so do your x first. And then from there, we're going to execute our slope of negative 6, down 6 over 1. So down 1, 2, 3, 4, 5, 6, and over 1. And our graph is kind of small, so we're not going to be able to do any more than that. But we can go ahead and draw a line, sort of, through this. And there you go. There are your graphs through for 4, 5, and 6. Okay? So we can now say if you know 2 points on a line, or if you know 1 point in the slope of a line, you can find the equation using the formula y minus y1 equals m times x minus x1. And I'm going to go back over to the other version here so that I can type into this and say, hey, that's the point slope form. We know what that form is called, point slope form, because there's a point and there's a slope. So the 7 through 10 says use the given information to write an equation for each line. Well, if we have slope and an intercept, then we can use the slope-intercept form. If we have a point and a slope, then we can use the point-slope form. So we're going to practice this a couple of different ways here. So for 7, we're given the slope and we're given the y-intercept. So we're just going to use slope-intercept form. Y equals, always start with that, the slope, which is negative 1, and then x, and then our y-intercept here, which is positive 6. Now you wouldn't see negative 1x in a textbook. You don't really need that 1 here. You would just say negative x. So let's go ahead and retype that. We can say or y equals negative x plus 6. Okay, so that's really what you would see for number 7. For number 8, same situation. You are going to start with your slope. Well, you can start with y equals. Then you're going to start with your slope. Y equals 4/5. Test me by making me write a fraction. 4/5. I just want to make it all fit here. Sorry, that's not pretty. Okay, and we'll put x after that. And then we have our y-intercept of negative 3, so minus 3. So there's our equation for number 8. So for numbers 9 and 10, we're going to need to identify the slope and a point before we can do anything else. So let's switch colors here. Let's go green. Okay, so our slope, m, equals, okay, from one point to the other, we go down 1, 2, 3, and over 1. Down 3 over 1. So we have negative 3 over 1. So slope is simply negative 3. Over here on number 10, we can do similar thing. We can look at one point to the other. We go down 1 and over 1, 2, 3, 4. Down 1 over 1, 2, 3, 4. So negative 1/4 is our slope. I'm going to back that up just a little bit. M equals negative 1/4. And I'll probably freehand that so you can see the fraction really well. 1/4. Hopefully you can see that negative in front of it, or you can listen. Okay, so as far as a point on the graph, you can really choose any one you want. People usually have a tendency to pick the smaller numbers, but really all the numbers are small here. You have a point at negative 3, positive 1, and negative 2, negative 2. I'm going to go with negative 3, positive 1. So we have a point at negative 3, comma 1. And over on number 10, we also have a couple points. We have a point at negative 3, negative 1, and we have a point at 1 and negative 2. Let's go with 1 and negative 2. And this is completely arbitrary. You can choose whichever point you want. But since we have the slope and a point, we can write this in point slope form. So I'm going to say y minus y1. My y value of my point is 1 equals the slope, which is negative 3 times x minus x1. So it would be minus a negative 3, so I'm just going to go ahead and say plus 3, because I know that minus a negative is the same thing as a positive. So there is my equation, my line in point slope form. Perfectly valid form of the line. And over here on number 10, same form, because I have slope and a point, so I'm going to write this in point slope form. So I have y minus my y value. And again, my y value here is negative, so it'd be minus negative 2, which is the same thing as plus 2, equals my slope, which is 1, and then x minus my x value. I'm sorry, I messed it up. Did y'all catch that? The slope is negative 1/4. We can't have that. Okay, so our slope here is negative 1/4. But a teeny tiny 1. Let's make that a little bit longer. Try to. Okay, that's a little better. All right, so our y value is negative 2. Our slope was negative 1/4. And now we have x minus our x value. And our x value is 1. All right, so there is our point slope form for number 10. 11 and 12 require a little bit more work, simply because you have 2 points here. You don't have a slope at all. So first we need to find the slope. We're going to find the slope by using our slope formula, which is what we did up here in numbers 1, 2, and 3. So we're going to do that very same thing to find our slope first for numbers 11 and 12. I know I'm kind of going fast here, but this is going to be saved to Canvas so you can watch it over and over and over again. So we are going to start by changing color. So we like color. Here we go. We're going to use blue this time. And we're going to find our slopes first for numbers 11 and 12. So I'm going to make a place to put our y2 minus y1 and our x2 minus x1 on both of these so we can simplify. I'm just assuming I need that much space. Okay, and then I'll just be able to type into it. Now once I find my slope, I can take that and either point and write my equation in point slope form. And if I wanted to, I could then solve that for y and put it in slope intercept form, which is what they did in this example up here, that first example on that first page. Okay, so here we go. We have y2 minus y1. Our y2 value is negative 2 and our y1 value is negative 4. So negative 2 minus negative 4 is the same as negative 2 plus 4. Okay, and then our x values are 2 minus 7. x2 minus x1 is 2 minus 7. And we're simplifying. I'm going to scoot that down just a smidge if I can. Will it let me? Maybe not. I'll just go ahead and type it again. Okay, so simplifying here. Negative 2 plus 4 is the same thing as 4 minus 2, which is just a positive 2. And then in our denominator, we have 2 minus 7, which is negative 5. So we end up with negative 2/5 for our slope. Negative 2/5 for our slope. Okay. And then we can take that slope, and either one of these points, I'll probably use this. Actually, it really doesn't matter. I'm just putting it in a formula. So I can just use the 7 and -4. Let's do that in just a minute. Let's go ahead and do the slope for number 12. We have y2 minus y1, or 1 minus 5. 1 minus 5. And then the x2 minus x1 is -6 minus 3. -6 minus 3. And we're simplifying. On top, 1 minus 5 is, of course, -4. And in the denominator, -6 minus 3 is, of course, -9. Two negatives make a positive, two wrongs make a right, so we do end up with 4/9, positive 4/9 for our slope. It's not pretty, but it is what it is. That's our slope. Okay, so now we're going to take our slopes and our points, and we are going to first change color and go ahead and put these in an equation form. So we're going to use point slope form because we have point slope. Okay, here we go. So y minus our y value. I'm going to go ahead and use this first one. So this is my y value here. So -4 minus a negative is the same thing as plus. So I have y plus 4 equals my slope, which was -2/5. -2/5. Okay. And then we have, in parentheses, our x minus x1. So we have x minus, and our x value is 7. So x minus 7. And that's it. That's your equation for number 11. It's really that easy. So for number 12, we're doing the same thing over here. Y minus our y value. Again, I'm going to choose this first point. And it's really arbitrary. You could choose the other point if you would like. Equals, and then our slope, which is 4/9. 4/9. Okay. And that's going to be times x minus x1. In parentheses, x minus, and our x value of that same point is 3. So make sure that you remember which point you started with, which point you're coming from, so that you can be consistent with your answers there. 13, 14, and 15, I'm going to move again to the other version because you'll be able to see here that I changed some values here so that we could actually plot these and graph them. We're not going to graph x equals 24 or y equals 22. We needed some more reasonable numbers, and I really wanted a negative in here. So we're going to do these in different colors. So we're going to do y minus 4 in orange. So y minus 4, or I'm sorry, not y minus 4, y equals 4. Y equals 4. So we're going to graph y equals 4. So on the y-axis, 4. 1, 2, 3, 4. This is 4 on the y-axis. And it just so happens that y also equals 4 here, and here, and here, and here, and anywhere else on this horizontal line. So this is the line, oh, I lost it, y equals 4 right there. Put arrows on the end to indicate that it does go on forever and ever. And that's the line y equals 4. So the y lines are perfectly horizontal lines that go through that point, whatever that point is, on the y-axis. So let's look at the next one. Let's look at x equals 7. Graphing the line x equals 7, again, is going to the point on the x-axis where it is 7. 1, 2, 3, 4, 5, 6, 7, which is right here. And it just so happens that x also equals 7 here, 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 and anywhere straight up or down from x equals 7. And that is the line x equals 7. It is a perfectly vertical line that goes through 7 on the x-axis. Okay? One more. Let's look at the line y equals -9. Looking at the line y equals -9. So on the y-axis, we're going all the way down here to -9. We're going to put a point. And note that y is -9 at all of these points, directly to the left and right of where it crosses that y-axis. And that's our line. It's a perfectly horizontal line that goes through the -9 on the y-axis. So there are some examples of graphing y equals and x equals lines. So the last three that we have here are writing equations in slope-intercept form. Now we have these equations in point-slope form, so what we're going to do here, is there more room over here? Maybe not, I don't know. We are going to start by distributing through the parentheses and then moving that one value away from the y. Just like this example over here. Up here, you have the equation of point slope form. To put it in slope intercept form, all you do is distribute and then move that one number away from the y. When you move something across the y-axis, remember that you do the opposite operation. So on number 16, we will add 7 to both sides after we distribute. On number 17, we will subtract 2 from both sides after we distribute. And on number 18, we will subtract 5 from both sides after we distribute. So let's do that. What color have we not used recently? Green? Okay. So we'll go back to green. Okay, so we'll start by distributing. I'm going to distribute the -2 through the parentheses here. I'm going to distribute the 1/3 through the parentheses here. Hope this is okay that I just do all these at the same time. And the -3/2 through the parentheses here. Okay, so when I distribute, I'm just going to rewrite my left side because that hasn't changed. Right now we are just distributing and dealing with the right side. So -2 times x is -2x, and then -2 times -1 is +2. So that will be our next step after we have distributed. Okay, so then all we need to do is add 7 to both sides, and I'm going to, I don't know what that is. I'm going to change color for that also. Okay, so here I'm going to add 7 to both sides. Add 7, and that will allow me then to change color again, write my final answer, which will be in slope intercept form. So on this left side, that -7 plus 7 cancel out, and I end up with just a y on the left side. Okay, and on the right side, I can bring down my -2x, and I have +2 plus 7. 2 plus 7 is, of course, 9. Oops, plus 9. So that ends up being my y-intercept. So if you have something in point slope form and you change it to slope intercept form, that's going to give you the freedom of being able to see what is your y-intercept and what is your slope. I mean, you can already see your slope, but it allows you to be able to see your y-intercept. So now you can see that 9 is your y-intercept. You can say, oh, look at that. So this is where my graph is going to cross the y-axis. So that's neat. That's definitely something that's going to be handy to know someday, like a year ago. Okay, so on 17, when we start by distributing, again, I'm going to just rewrite the left side. I have y plus 2 on the left. And on the right, oh, that's a terrible 2, forgive me. On the right, I've distributed the 1/3 through the parentheses. 1/3 times x is simply 1/3 x. 1/3 x. Please do not feel like you have to change fractions to decimals. Don't be afraid of fractions. They're real life. If you ever cook, you're going to need the fractions. 1/3 times 5 is 5/3. So plus 5/3 over here. 5/3. And we're going to need to be a little bit fraction savvy here so that we can simplify this equation further. What I'm saying is this. Let me change colors first. I know I love to change color. All right. When I subtract 2 from both sides, I can subtract 2 from both sides if I have it in the same form here. When I combine fractions, I need the denominators to be the same. Right now, I have 2 over 1. So I need to change 2 over 1 to 6 over 3. 6 over 3 is the same thing. So when I subtract 2 from both sides, over here, instead of subtracting 2, I'm going to subtract 6 over 3 because that is 2. That is the same thing as 2. 6 divided by 3 is 2. So it just puts it in the same form. Hope y'all followed that. Okay, then all we have left to do is change color and write our final answer here. Okay, so 2 minus 2, of course, is going to cancel out. And on the left side, I'm just left with y. Try not to make this too messy. My slope and my x are the same, so I still have 1/3 x. But I'm getting ready to find out what my y-intercept is, which will be glorious. Then we will know, and there will be no more mystery on that front. Okay, so we have 5/3 minus 6/3. So when you are combining fractions and your denominator is the same, keep your denominator and just deal with the numerators. 5 minus 6 is negative 1, so I have minus 1/3. 1/3. Come on, 3. Don't be super ugly. There we go. So it turns out that negative 1/3 here is our y-intercept because our equation is y equals 1/3 x minus 1/3. So negative 1/3 is where this would cross the y-axis, would be really just under the 0 point there. All right, so looking at 18, pretty much like 17. You are going to distribute, and it's going to be not the prettiest thing because you're distributing with a fraction, but that's okay. We can do it. All right, we're going to start with blue this time. Okay, so when I distribute this, I'm going to rewrite my left side because it has not changed. So I'm rewriting it as y plus 5. Okay, equals. And then when I distribute here, negative 3 over 2x is simply negative 3 over 2x. Negative 3 over 2 times x. Negative 3 over 2 times x. Okay, so pay attention here. Negative 3 over 2 times negative 3. Negative times negative gives me a positive. Okay, 3 over 2 times 3 is the same as saying 3 over 2 times 3 over 1. Multiply across the top and the bottom, and I end up with 9 on top, which is 3 times 3. And on bottom, 2 times 1 is simply 2. All right, that wasn't too bad, hopefully. That's unique looking 2 there. So I'm going to change colors again so that I can see what's happening in this next step. All right, so I need to subtract 5 from both sides. But again, if I'm going to be subtracting 5 from 9 over 2, then I need 5 in a form that has 2 in the denominator. So 5 is the same thing as 10 over 2, so I'm going to subtract 10 over 2 from both sides. I do hope y'all are following that. 10 over 2. Okay, and I'm going to change colors one more time. Go back to the green. Okay, positive 5 minus 5 cancels out. And on the left side, I'm left with just y equals. And then my slope and my x stay the same. I have negative 3 over 2x, negative 3 over 2x. So if I was graphing this, I would go down 3 and 2 to the right for my slope. Then I just need to simplify this to find out at long last what is my y-intercept. 9 over 2 minus 10 over 2. So again, when you are combining fractions, the denominator is the same, leave them alone and just deal with the numerators. Numerators here are 9 minus 10, which is of course negative 1, so I have negative 1/2. There it is. Negative 1/2 is my y-intercept. That is where my line will cross the y-axis. So I am actually going to show that here because I have room to show that. I didn't on the other one, sorry about that. So here, can show that negative 1/2 is in fact my y-intercept. This is a beautiful thing. It's a great place to start when you're graphing a line. Start at the y-intercept and then execute your slope from that y-intercept. All right, I hope this has been super, super helpful. I am going to save and post these notes to Canvas, and I'm going to save and post these notes to Canvas so that you can have the benefit of those graphs. Thank you so much for coming.